So welcome to part 2 of lecture number 8. The topic is 1.12 dipole in a uniform external field. In part 1 we have already discussed few fundamentals about the torque. So let us start the theory. Dipole in a uniform external field. So if we see this external field, that means the field which is provided from outside. It is not the field due to dipole. Okay, dipole's field is different, but this field has been provided by some external agency, right? Another word is uniform, that means the field is not changing. If the position is changing, the field is uniform everywhere, right? So let us consider a uniform magnetic field which is shown in this figure. You can see that the field lines are there which is going upward. Okay, and you can see that they are uniform. You can see that the distance between the lines is same, and the vector length of each and every field line is also same, right? Now that is uniform external field. Now let us put a dipole in this external field, right? So let us consider a dipole. Okay, so what we have discussed in our previous lecture, first thing you should show is the charge. Okay, so let us show that over here there is a positive charge, so I will denote it with q, right? Okay, over here there is a negative charge and I will show it with minus q. I will show it with minus q. Second thing you should show in your diagram is the center of the dipole. Okay, so here is the center of the dipole and I will denote it with O. Okay, it is origin, so I am just denoting it with O. Next thing you should show is the distance between the two dipoles. Okay, so over here यहाँ पे अगर मैं ये लाइन को पैरेलल, इसमें एक पैरेलल लाइन दिखा दूँ. ओके, यहाँ पे मैं एक पैरेलल लाइन दिखा देता हूँ. ओके, एंड आई कैन से दैट द डिस्टेंस बिटवीन दिस टू पॉइंट्स इज 2a as we have seen it in our previous theory. So that is 2a, right? Okay, and from origin to any charge the distance is half, that is equals to a. So o to q plus q distance is a, o to minus q distance is also a. Next thing you should show in dipole is its direction. Okay, so what we have studied, what should be the axis direction? It is always from minus q to plus q. So let us show the direction. So here is the direction. Okay, ये direction है, minus q to plus q is the direction of the dipole, right? In our previous lecture we have also discussed about the dipole moment. So the equation for the magnitude of the dipole moment we discussed was q into 2a, right? And we also discussed that the direction of the dipole moment is same as the direction of dipole, right? These two are same. So over here I can also write that the dipole moment is having a same direction. This is a dipole moment and it has same direction, minus q to q, right? Okay, now let us discuss about the angle. Okay, so as you can see over here, अगर मैं पॉइंट O को यहाँ पे रीड्रॉ कर रहा हूँ. ओके, so let us say this is the line which is passing from point O. Okay, this is a vertical line. Okay, this is point O, and then after this is just a horizontal line, and over here the dipole is there. Say this is Q. So the angle which is making with the vertical is, let us say, theta. Okay, dipole axis है, जो dipole axis है, okay, it is making an angle of theta with the electric field lines, right? Okay, so I can show it over here. Say this is the angle which is equals to theta, right? Okay, now next thing is let us show the forces. Okay, So we'll find out the force which is acting on charge plus q, right? So you can see that over here the force will be in the direction of the field. So this is the direction of the field, okay? Sorry, this is the direction of the force, okay? What was the equation to find out the force? So we have understood that F, force on any charge, can be given as Q multiplied with the electric field, which is equals to E. So same thing I can write over here. Say over here how much force is there, so I can write it as Q into E, and it is upward direction, it is in upward direction, right? Same way over here for minus q I can write the same force, but as the charge is minus q over here, so you can understand that the force is in downward direction, right? तो एक अपवर्ड है, दूसरा है वो डाउनवर्ड है. अगर मैं ये डाइपोल को एक पेन से रिप्लेस कर दूं एंड द फोर्स एक्टिंग इज अपवर्ड, over here the force which is acting is downward, so you can understand that it is going to rotate the dipole in anti-clockwise direction. It is going to rotate it in anti-clockwise direction. Okay, ये थोड़ा सा रोटेट होगा, पूरा कंटिन्यूसली रोटेट नहीं होता है. It will just rotate and it will be aligned with the direction of electric field. तो ये इतना ही रोटेशन होगा इसमें, right? Okay, so yeah, so we were talking about the theta, and then after what is the effect on dipole due to this external field. So I hope you have understood that. Okay, now let us talk about the magnitude. Okay, यहाँ पे rotation हुआ है, इसका मतलब है कि the fundamentals of torque is applicable. Okay, so what we have discussed, अगर हम torque के बारे में बात करें, then torque's magnitude क्या होगा वो, it equals the magnitude of each force multiplied by the arm of the couple. So over here हमें torque के बारे में लिखना है, tau magnitude of torque can be given as how much is the force, so force is q into e, okay, multiplied with the distance between the arm, but we have to take perpendicular distance. Okay, तो ये कैसे फाइंड आउट करना है perpendicular distance? That means I have to move this dipole like this on the x axis such that कि ये जो vertical line है उससे एंगल है वो 90 डिग्री का हो जाए. सो इफ आई विल ट्रेस दिस, अगर मैं इस लाइन को रोटेट करके हॉरिजॉन्टल बना देता हूँ, देन आई विल गेट डिस्टेंस. ओके, सो दिस इज द डिस्टेंस. मैंने क्या किया, इस लाइन को यहाँ पे ट्रेस कर दिया है, इस लाइन को यहाँ पे ट्रेस कर दिया है, एंड दैट इज हाउ दिस इज गोइंग टू बी 2a into sin theta. This is 2a into sin theta, that is the perpendicular distance. So I am going to write that thing. यहाँ पे आएगा 2a sin theta, right? So again I can write it like this, 2qa e sin theta. Mind well, this is just a magnitude of the torque. Okay, now what we know that 2qa over here, 2qa is equals to the vector magnitude of the vector p. Okay, that is the dipole moment. So I can also represent it like this. This is magnitude of vector p multiplied with e sin theta, right? Okay, now what we know is, suppose vector c is there, then I can represent it with a cross product, and if I want to find out its magnitude, then it can be given as a b sin थीटा. ओके, अभी आप इसका रिवर्स सोचो, ए बी साइन थीटा दिया है, सो यू कैन ऑलवेज रिप्रेजेंट इट एज ए क्रॉस बी, राइट? सो सेम वे ओवर हियर यू कैन रिप्रेजेंट दिस थिंग विथ वेक्टर पी क्रॉस वेक्टर ई इज इक्वल्स टू द टॉर्क. ओके, सो टाउ टॉर्क कैन बी गिवन एज पी क्रॉस ई, राइट? ओके, नाउ लेट अस कम, हमने मैग्नीट्यूड की बात कर ली. नाउ लेट अस टॉक अबाउट द डायरेक्शन ऑफ द टॉर्क. ओके, सो एज वी हैव डिस्कस इन आवर प्रीवियस लेक्चर, यहाँ पे आप पहले फाइंड आउट करो कि इन विच डायरेक्शन द डाइपोल इज गोइंग टू रोटेट। ओके, सो हमने पहले ही देखा कि ये इस एंटी क्लॉकवाइज डायरेक्शन में घूमने वाला है, वी हैव ऑलरेडी डिस्कस। सो यू कर्ल योर फिंगर एंटी क्लॉकवाइज and the thumb will show you the direction of the torque. So you can say that in this case the torque is coming out, direction of the torque is out from the plane of the paper, right? Okay,